Hello learners, and welcome to our grade 8 integrated science revision lesson. In this video, we are going to work through 40 examination style questions covering major grade 8 topics. And for each question, try to choose your answer before I explain it. I will not only tell you the correct option, I am going to explain why it is correct, and I will show you what is wrong with the other choices where necessary. And also we are going to connect the question to other facts that you should remember for any other exam that you may encounter. Now let us begin, and we are going to handle various topics. For example, we'll start with elements and compounds for question 1. Now let us start. Question 1. Which statement best describes an atom? A. A basic particle that makes up an element. B. A mixture of two or more substances. C. A group of different compounds. And D. A substance that can always be separated physically. So the correct answer is option A, a basic particle that makes up an element, because an atom is one of the best building blocks of matter, and an element contains only one type of atom. For example, copper is made up of copper atoms, and oxygen is made up of oxygen atoms. And for option B states a mixture of two or more substances. That describes a mixture, it's not an atom. And option C talks about compounds, which are made when atoms of different elements combine chemically. Then option D says that a substance that can always be separated physically. Now that is also incorrect, because whether a substance can be separated physically depends on whether it is a mixture, not whether it is an atom. Now one of the most important things you are supposed to understand is that atoms make up an element, and atoms can join to form molecules, and atoms of different elements can combine to form compounds. For example, water is made up of hydrogen and oxygen atoms. Now, if a question asks for the simplest particle in this topic, you are supposed to first decide whether it is asking about an atom, a molecule, an element, a compound, or a mixture. And then with that, you should be correct. Now, question 2. What is the correct chemical symbol for copper? So we have A, CO, we have B, Cu, we have C, Cp, and D, C. The correct option is B, Cu, because chemical symbols are short, internationally accepted ways of representing elements, and copper is written as Cu with a capital C and a small u, and then Co is the symbol for cobalt, while C is the symbol for carbon. You see, Cp is not the accepted symbol for copper. It is not a representative of any element. Now, as a learner, you should always remember that some symbols come from English names, such as O for oxygen and N for nitrogen, while others come from older or Latin names, which is why the symbol may not look exactly like the English word. Now, some of the important symbols that you're always supposed to remember is that H is for hydrogen, O is for oxygen, C is for copper, N is for nitrogen, Fe is for iron, Al is for aluminium, Cu for copper, and then Ag is for silver, and then Au is for gold, then Cl, capital C small l, for chlorine, and then Na, capital N small a, is for sodium, Hg, capital H small g, is for mercury, and Pb, capital B, capital P small b, for lead. Now symbols are case sensitive, very important. For example, for mercury, you cannot write capital H and capital G, because symbols are case sensitive when it comes to elements. So changing a capital letter to a small letter can make the answer wrong. If it is capital, it should remain capital. If it is small, it must remain small. So I hope that you cannot fail a question that is involving symbols. You should know the elements of the periodic table and the symbols and what every symbol represents. Let us now go to question number 3. Which one of the following substances is a compound? A. Oxygen, B. Copper, C. Water, and D. Gold. Now the correct option is C. Water, because water is a compound because it contains hydrogen and oxygen. They are chemically combined in a fixed relationship. Oxygen, copper, and gold are elements because it contains only one type of atom. This is an important distinction, that an element cannot be broken down into simpler substances by ordinary chemical means, while a compound contains two or more different elements chemically joined. Also remember that an element can exist as molecules. Oxygen gas, for example, contains oxygen molecules, but it is still an element because these molecules contain only two oxygen atoms. Then in a compound, the elements lose some of their individual properties and the compound has its own properties. Exam tip for this type of questions is that do not assume that every molecule is a compound. Ask whether the particles contain one type of atom or different types of atoms. And then with that now, let us go to question number 4. Which word equation correctly represents the formation of carbon dioxide? We have A. Carbon plus oxygen is equals to carbon dioxide. B. Carbon dioxide plus oxygen is equals to carbon. Then C. Carbon plus water to give us carbon dioxide. Then D. Oxygen plus water to give us carbon dioxide. That question is not hard. The correct option is A. Carbon plus oxygen gives carbon dioxide. Our equation shows the substances that react on the left and substances that are formed. On the left it is the substances that are reacting. On the right it is substances that are formed. And here carbon is supposed to react with oxygen to give us carbon dioxide. So CO2. So C plus O2, it gives us CO2, which is carbon dioxide. And the arrow can be read as producers or forms. So option B reverses the reaction, while option C and D introduce water, even though water is not one of the reactants needed in this simple word equation. So other examples that you may encounter in your exam include hydrogen plus oxygen forming water, sodium plus chlorine to form sodium chloride, and then copper plus oxygen to form copper oxide, aluminium plus oxygen forming aluminium oxide. And these are some of the simple equations you should know. Now, for an exam tip, in word equations, you are supposed to identify the reactants first. You see, you should know what is reacting and then what product is formed after that reaction. Never put a product on the reactant side simply because its name contains the same element. Then let us go to question number 5. Which one of the following is a common use of copper? We have A. Electric wiring. We have B. Filling balloons. We have C. Making table salt. And D. Producing oxygen for breathing. That is very easy. The correct option is A. Electrical wiring, because copper is widely used in electrical wires because it conducts electricity well and it can be drawn into wires. Now the other option do not describe a common use of copper because different elements have different uses based on their properties. For example, aluminium is useful in construction and many lightweight objects, while gold and silver are useful in jewelry and medals. Iron, on the other hand, is important in construction and chlorine is used in water treatment. Now, another thing is that oxygen is useful in respiration and it has other medical uses. The wider lesson is that properties help determine the uses. So, for good electrical conductors, we need to use copper because it helps in wiring, and strong materials are useful in construction, and attractive, less reactive metals may be used in jewelry like gold and silver. Now for your exam tip, when you are asked about the use of an element, you are supposed to connect the use to property rather than memorizing a random list. Just need to know if it is copper, can it conduct electricity? If yes, then it should be very much usable when it comes to electrical wiring. Let me first explain that for question 1 to 5, we were looking at elements and compounds. I have organized these questions in a way that we are evaluating one topic after another. So we were looking at elements and compounds from 1 to 5, and then from question 6 all the way to question 12, we are now going to be looking at physical and chemical changes. Then after there, we are going to look at classes of fire and fire safety. So I hope that you get this. So let us now go to question number 6, where we begin physical and chemical changes. Which element correctly describes particles in a gas? A. They are tightly packed in fixed positions. B. They are close together and only vibrate. C. They are far apart and move freely. And then D. They have no motion at all. So question 6 is not hard. The correct option is C, is that gas particles are far apart and they move freely. Now in the kinetic theory of matter, solids, liquids and gases differ because of the arrangement and movement of their particles. In solid, particles are closely packed and mainly vibrate around fixed positions. Then in liquid, particles are still close together but can move past one another. And then in gases, particles are much further apart and they move rapidly in many directions. That is why gases can spread out and fill a container while solids keep a fixed shape. So option A describes a solid, option B is closer to so option A describes a solid and option B is closer to a solid than a gas. Then option D is wrong because particles are always moving and the amount and type of movement differ with the state. So for your exam tip, you should always remember that for particles questions, you should revise 3 things together. Spacing. So for liquids, gases and solids, you should know about spacing of particles. You should know about movement, how they move, and also the strength of attraction. Let us go to question number 7. Question 7. Which one of the following is a physical change? A. Rusting of iron. B. Burning charcoal. C. Melting ice. And D. Cooking an egg. So the correct option is C. Melting ice. Because melting is a physical change. Because the substances remain water. Only its state change from solid to liquid. Rusting, burning charcoal and cooking an egg involves chemical changes because new substances are formed and the original material cannot easily be returned to their starting form. Now, physical changes may involve changing in state, in size, in shape or appearance without producing a new substance. Examples include freezing water, melting wax, dissolving substances, and cutting a material. But chemical changes include burning, rusting, and many reactions that produce gases or color changes. Others lead to precipitation or new substances formed. So for such type of questions, they are very, very common. You should always remember that the strongest question to ask is this: has a new substance been formed? And if yes, if a new substance was formed, it is usually a chemical change. But if no substance was formed, then if no new substance was formed, then it is usually a physical change. Let us now go to question number 8. Rusting of iron is a chemical change because A. The iron only changes shape. B. A new substance is formed. C. The change is always temporary. And D. The iron simply melts. So for question 8, like I was explaining in question 7, is that the correct option is B. A new substance is formed. During rusting, remember that iron reacts with substances in the environment, especially oxygen and moisture, to form rust, which has different properties from the original iron, and this makes rusting a chemical change. A simple change in shape would be physical, and iron does not rust because it melts. You see, chemical changes are often difficult to reverse also by simple physical methods because chemical bonds and particle arrangements have changed. Other examples of chemical reactions I had explained, but let me state them again. They include burning wood, cooking food, and reactions that form new compounds. So the wider lesson is to look for evidence of chemical change such as formation of new substances, color changes, gas production, temperature change, or formation of solid from solutions. Now, not every color change proves a reaction by itself, so use the whole situation and ask whether a new substance has formed. Let us now go to question number 9. A learner opens a bottle of perfume at one corner of a room. After some time, the smell is detected across the room. This is mainly due to, we have A, osmosis, B, diffusion, C, freezing, and D, condensation. That is easy. The correct option is B, diffusion. Why? Because diffusion is the movement of particles from a region where they are more concentrated to a region where they are less concentrated. Now, when perfume is opened, many perfume particles are near the bottle. So, their random motion causes them to spread through the air until the smell can be detected further away. On the other hand, let us look at the other options. We have osmosis. Osmosis is different because it specifically involves water moving through a selectively permeable membrane. Then freezing is not correct because freezing and condensation, they are just changes of state. Those two, they indicate changes of state and not the spreading process that is described here. But for our correct option, diffusion, remember that diffusion happens in gases and liquids and is generally faster in gases because gas particles move freely. So when you see a question about a smell or colored substances spreading without stirring, diffusion is a strong possibility. And if the question involves water crossing a membrane, think of osmosis instead. Then now we go to question number 10. What generally happens to the boiling point of pure water when the salt is dissolved in it? Number A, it increases. Number B, it becomes zero. Number C, it decreases greatly. And number D, it remains exactly the same. The correct option is A, is that the boiling point increases. Why? Because when you dissolve salt in pure water, this makes the water impure. And a dissolved non-volatile substance such as salt generally raises the boiling point. Impurities also lower the melting point or the freezing point of a substance, and this is why pure and impure substances may not boil or melt at exactly the same temperature. The boiling point is the temperature at which a liquid is changing state from liquid to gas throughout the liquid. The melting point is the point at which or the temperature at which a solid changes to liquid, so it's melting. So as a learner in grade 8, you are not just to memorize temperature, but you are supposed to understand that impurities affect the changes of state. And for your exam tip, always remember the common school rule for dissolved salt. Boiling point goes up while freezing point or melting point goes down. When impurities are added to substances, they lead to a higher boiling point and a lower freezing or melting point. Then we go to question number 11. When a pure solid is melting, the temperature remains constant for a time because the supplied heat is mainly used to, we have A, to change the state of the substance, B, reduce the mass of the substance, C, to stop the particles from moving, and D, to turn the substance into new element. Now this question is also very easy. The correct option is A, that the supplied heat is mainly being used to change the state of the substance. On heating curve for a pure substance, the temperature rises while the substance is warming. During melting, however, there is a period when temperature stays constant even though heat is still being supplied. The energy is being used to overcome forces holding particles in their solid arrangement so that the substances can become liquid. A similar flat section may occur during boiling. The mass does not suddenly decrease simply because the melting is happening, and particles do not stop moving, and the substance does not become a new element. Now, an exam tip for such type of question is that on a heating curve, sloping sections usually show temperature change, while flat sections usually show a change of state at constant temperature for pure substance. Then now let us go to question number 12. Which statement best distinguishes a chemical change from a physical change? We have A, A chemical change always changes the size of substance. We have B. A chemical change forms one or more new substances. And then C. A physical change always produces heat. D. A physical change cannot be reversed. The correct option is B. And now after question 12, we are done with physical and chemical changes. Now from question number 13 to 17, we are going to be looking at classes of fire and fire safety. Let us start with question number 13. Which three things are needed for a fire to continue burning? Option A, fuel, oxygen and heat. B, water, air and soil. C, fuel, carbon dioxide and water. D, heat, smoke and ash. The correct answer is option A, fuel, oxygen and heat, because these three components make up the fire triangle. Fuel is the material that burns, oxygen supports combustion, and enough heat is needed to start and maintain the burning process. If any of these three is removed, the fire can be controlled or extinguished. Water, soil, smoke and ash are not the three essential components of fire triangle, and this idea explains why many fire control methods include cooling with water where it is safe and appropriate, removing heat, covering a small fire, and this explains why many fire control methods include cooling with water where it is safe or removing heat. You know, covering a small fire can also help to reduce oxygen. It is also a method that is highly used. Also, turning off gas supply removes fuel. For an exam tip, if a question asks how a fire control method works, you are supposed to connect it with the fire triangle. Is it removing heat? Is it removing oxygen? Or is it removing the fuel? Now let us go to question number 14. Covering a small burning cooking pan with a suitable lid can put out fire mainly because it A, adds more fuel. B, removes oxygen from the fire. C, raises the temperature. And D, produces more flame. So the correct option is B. It removes or greatly reduces the oxygen reaching the fire, because a small pan fire can sometimes be controlled by carefully covering it with a suitable lid or fire blanket, and provided this can be done safely. The cover separates the flames from the air, breaking the oxygen side of the fire triangle. It does not add fuel to raise the temperature. You see, this is called smothering a fire. As a learner, you are supposed to know that different fires require different control methods, and unsafe actions can make a fire worse. For example, throwing water into burning cooking oil can spread the burning liquid. You see, so for an exam tip, in questions about covering, blanketing or smothering a fire, the component being removed is oxygen, and in questions about cooling, the component being reduced is heat. Then we go to question number 15. Why should water not be poured into live electrical equipment that is on fire? A, water can increase the risk of electric shock. B, water always makes all fire burn faster. C, water contains too much oxygen. And D, water changes electricity into fuel. Now the correct option is A, that water can increase the risk of electric shock when live electrical equipment is involved. Remember that ordinary water contains dissolved substances that allow electrical current to pass through it. So using water around live electricity can be dangerous. The first priority is personal safety, of course. You are supposed to avoid touching live equipment, and you are supposed to disconnect the electricity supply if it can be done safely. And you are also supposed to use appropriate fire control equipment. The other choices are scientifically incorrect because water does not always make every fire burn faster. It does not act as a fuel, and danger here is not that it contains too much oxygen. The wider lesson is that fire control depends on the type and the source of fire. For your exams, whenever electricity is still live, think about electrical safety before choosing a fire control method, because that electric current on itself can also be very, very harmful. Then we go to question number 16. Which action controls a fire mainly by removing the fuel source? A. Turning off the gas supply. B. Blowing air into the flame. C. Adding dry paper. D. Opening nearby windows. So for question 16, the correct answer is A. Turning off the gas supply. Because if a gas appliance is burning because of fuel continuous flow, safely shutting off the supply removes the fuel side of the fire triangle. However, blowing air on the flame adds oxygen and it may make the fire stronger. Adding paper supplies even more fuel. Also, opening windows can also increase the amount of oxygen available. So fire control questions often test whether you understand the principle rather than merely memorizing equipment names. A fire can be stopped by cooling it, smoothing it, or removing its fuel depending on the situation. Let us now go to question number 17. Which practice best helps to prevent fire accidents? A. Storing flammable substances near open flames. B. Leaving electrical appliances on when not in use. C. Keeping flammable materials away from sources of heat. And D. Allowing children to play with matches. Get the correct answer through elimination method. The correct option is C. Keeping flammable materials away from sources of heat. And why? Because fire prevention is safer than trying to fight a fire after it starts. Now, fighting a fire after it starts is not a good control method. It is better to prevent it. Things like flammable liquids, gases, paper, and other easily burning materials should be stored and kept away from open flames, sparks, and excessive heat. And this is going to help prevent fire. Now, with that, we are done with the classes of fire and safety and fire safety questions, 13 to 17. We are going to question 18, and from question 18 to 22, we are going to be looking at the cell. You know about the cell. So we are going to be looking at the cell, and let us begin with question number 18. The basic unit of structure and function in living organism is the. So we have options there. We have A, organ, B, cell, C, tissue, and D, system. The correct option there is B, the cell, because a cell is the basic unit of structure and function in living things. Tissues are grouped of similar cells working together, and organs are made up of different tissues working together. And an organ system contains organs that cooperate to perform major functions. So the order is from simpler to more complex. We start with cell, and then cells form tissues, and then tissues form organs, and then organs form systems, and then the systems form the organism. Some organisms consist of only one cell, while humans, plants, and many animals are multicellular and contain enormous number of specialized cells. Now, the wider lesson for you to understand at your level is that you are supposed to observe plant and cell animals under light microscopes, or you are supposed to know once you observe them what results are you going to see or what is going to be the difference. And for your exams, if a question asks for the smallest living structural unit, the answer is always a cell, not a tissue or an organ, because a tissue is made up of many cells. Then question number 19. Which structure is found in a typical plant cell but not in typical animal cells? Then we have our options there. We have A, cell wall, B, a cell membrane, we have C, cytoplasm, and D, nucleus, that is not hard. The correct option is A, the cell wall, because a typical plant, all the cells of a plant have cell wall outside the cell membrane, and the wall gives support and it helps the cell to maintain its shape. Both plant and cell animals have a cell membrane, a cytoplasm, and a nucleus. However, plant cells may also have a large vacuole, and in green tissues they have chloroplast. So those are the differences. And animal cells do not have a cell wall. This is one of the easiest features to use when comparing a diagram of a plant and an animal cell. Sometimes they'll give you a diagram, and in one of the cells there is a cell wall, and in the other one there is no cell wall. So you should always know if there is a wall, then that is a plant cell. An animal cell does not have it. So that is very important to know when you are comparing these two types of cells. And then now with that, let us go to question number 20. What is the main function of the nucleus in a cell? A. It controls cell activities. B. It makes the cell wall. And C. It stores air for the cell. D. It pumps blood around the body. The correct answer is option A, that it controls cell activities, because the nucleus contains genetic materials that act as a control center for many cell processes. The cell wall does not come from the nucleus as an answer to this question, and the nucleus does not store air or pump blood, so I am eliminating the other methods. Other cell parts have their own functions. The cell membrane controls movement of substances. Cytoplasm is where many chemical reactions occur, and the cell wall supports plant cells. Chloroplasts, on the other hand, are involved in photosynthesis, and the vacuole contains the cell sap in the plant cells. The wider lesson for you to understand is that structure and functions are connected. So when revising cell parts, you are supposed to use pairs such as nucleus control, membrane entry and exit, cell wall support, chloroplast photosynthesis, and cytoplasm reactions. Very important for you to revise those areas. Then we go to question number 21. Which cell structure controls the movement of substances into and out of the cell? We have A. Cell membrane, B. Nucleus, C. Cell wall, and D. vacuole. I'm sure that one everyone will get correct. The correct option is a cell membrane, because cell membranes form a boundary around the cell and it controls what enters and what leaves. This selective control is important because cells need useful substances such as water. They also need oxygen and they need nutrients while also removing waste. So the other options, what does the nucleus do? The nucleus controls the cell activities, and then the cell wall provides support in plant cells, and the vacuole mainly stores the cell sap in a plant cell. This question connects directly to the next topic, or the next thing we are going to look at about movement of materials in and out of cells, where diffusion and mosses are studied. You should always remember that there is a difference between cell wall and cell membrane. The wall mainly supports and protects a plant cell, while the membrane regulates movement of substances into and out of the cell. Then now let us go to question number 22. A microscope has a ×10 eyepiece lens and a ×40 objective lens. What is the total magnification? Now, this question is very easy. You are asked to identify total magnification, and we have our options there: A ×50, B ×400, and C ×30, and D ×4. The correct option is B ×400, and I'll tell you why. Because total microscope magnification is found by multiplying the magnification of the eyepiece lens and that of the objective lens. You do not add them. You are not supposed to add 10 and 40. You are supposed to multiply them. So whenever you get such kind of a question, you are given the eyepiece and you are given the objective lens, you are supposed to multiply the two. So 10 times 40, we get 400, and the correct option is B, 400. So from question 23, by the way, all the way to 26, we are looking at movement of materials in and out of the cell. Note that we have talked about the cell up to question 22. Now we are talking about movement of materials in and out of the cell up to question 26. With that, now we go to question number 23. Question 23. Diffusion is the movement of particles from a region of, we have A, low concentration to high concentration only, B, high concentration to low concentration, C, low temperature to high temperature only, D, high pressure to low pressure only. Now, the correct answer is option B, from a region of high concentration to a region of low concentration. Why? Because diffusion occurs when particles are in constant or random motion. Now, if there are many particles in one region and fewer in another region, there will be a net movement toward the less concentrated region until the particle become more or evenly spread. An example, we have seen such a question, perfume spreading in air. That is an example where gas is moving along the within the room. We also have gas exchange in the lungs. That is what happens, diffusion. Diffusion does not require a selectively permeable membrane. Actually, the difference between diffusion and osmosis, many students tend to confuse. For diffusion, there is no selectively permeable membrane, but when it comes to osmosis, there is a selectively permeable membrane. Now, although it can occur across one, diffusion can still occur across one. Now, that requirement is especially associated with osmosis when it comes to selectively permeable membrane. For your exam tip, you're always supposed to remember that the direction is moving from high concentration to low. If the question especially talks about water and selectively semi-permeable membrane or permeable membrane, then think of osmosis other than diffusion. Now we go to question number 24. So question 24, osmosis is the movement of, we have A, water molecules through a selectively permeable membrane, B, all particles from low to high concentration, then C, oxygen only through a solid wall, and D, food particles through the nucleus. That is very easy. I have already addressed it in question 23. The correct answer is A, water molecules. Osmosis is the movement of water molecules through a selectively permeable membrane. Osmosis is a special type of movement involving water. So mostly when we talk about osmosis, we are talking about water. And in simple terms, just look at it as water moving across a selectively permeable membrane from a region with more available water to a region with less available water. Then now we go to question number 25. Oxygen moves from the air into the lungs, into the blood, mainly by, we have A, diffusion, B, melting, C, freezing, and D, evaporation. So for this question, the correct option is A, diffusion. In the lungs, oxygen is at a higher concentration in the air spaces called alveoli than in the deoxygenated blood that is arriving in the lungs. So oxygen therefore is moving across thin surfaces into blood by diffusion. So carbon dioxide moves in the opposite direction from the blood into the alveoli, also by diffusion. So what is involved here is diffusion. The other options are not correct because melting, freezing, and evaporation are changes of state and they do not explain gas exchange within the lungs. Efficient diffusion is helped by thin exchange surfaces and concentration differences. And you should always remember that diffusion is essential in living organisms, not only in lab demonstrations, it is also very essential in how breathing occurs. Now, for your exams, when a question describes gases moving between the lung and the blood, always remember that the expected answer of that process is called diffusion. Then now we go to question number 26. Water enters root hair cells from the soil mainly by combustion, osmosis, condensation, or rusting. Also for question 26 here we see a very good example of osmosis. The correct option is B, osmosis, because water is in the soil is entering the root hair cells mainly by osmosis across their selectively permeable cell membrane. And root hair cells are well suited for absorption because their long extensions provide a large surface area in contact with soil water. And root hair cells are well suited for absorption because their long extensions provide a large surface area in contact with soil and water. Now, when it comes to the other options, combustion, condensation, and rusting, those are completely different processes and they do not involve they do not involve movement of water from soil to the root. Diffusion is also important in organisms, but when the question focuses on movement of water across a membrane, then osmosis is the key term. The water absorbed by roots can then move through the plant and support processes such as photosynthesis, transport, and maintaining the cell firmness. For your exam, always remember that root air plus water is a strong clue for osmosis. Do not confuse water absorption with mineral ion uptake, which may involve other transport processes. Then with that, now we are done with diffusion. We are done with movement of materials in and out of the cell. We are looking at reproduction in human beings from question 27 to 31. So we start with question 27. Menstruation occurs when A. The lining of the uterus is shed when pregnancy has not occurred. B. A sperm cell fuses with an egg. C. An embryo attaches to the uterus. And D. The lungs exchange gases. So that is very easy. The correct option is A. When pregnancy has not occurred. You see? So because menstruation is the shedding of the uterine lining when pregnancy has not occurred. During menstrual cycle, what is happening is that the lining of the uterus builds up in preparation for possible pregnancy. That is before menstrual cycle. If fertilization and successful implantation does not occur, then part of this lining is shed as menstrual flow. Option B, it is talking about fusion of a sperm cell and an egg. That is fertilization. What about C? An embryo attaches to the uterus. Now that is called implantation. And D is unrelated to reproduction. Now as a learner, you should always understand that menstrual cycles can vary from person to person and that challenges such as pain, irregular periods, or unusual bleeding may need appropriate support or medical advice. That is a very common question. And also remember that you are supposed to separate the sequence clearly. You are supposed to know about maturation and release of an egg. You are supposed to know about possible fertilization, possible implantation. If pregnancy does not occur, what happens? And you're also supposed to understand about menstruation. All these things, they are very much testable in your papers. Then now let us go to question number 28. Fertilization in human beings is the A. Release of an egg from the ovary. B. Fusion of a sperm cell and an egg cell. C. Shedding of the uterine lining. And D. Growth of a baby after birth. So for question 28, the correct option is B. The fusion of a sperm cell and an egg. You see, an egg cell. Fertilization combines the male and the female reproductive cells to form the first cell of a new individual. Option A describes ovulation. You see, option A talks about release of an egg from the ovary. That is what we call fertilization. And then option C, shedding of the uterine lining. That is menstruation. You see, so it is not the correct answer. Then growth of a baby after birth, that occurs much later after fertilization, and even the embryo has grown and the baby has been born. Now, with that, some of the things you are supposed to understand in this topic is that in humans, fertilization normally happens in the oviduct or the fallopian tube. Then the developing structure then moves towards the uterus, where implantation may occur. For you, you are supposed to focus in the process and sequence rather than the detailed hormonal control, because that is what is taught at this level. And for your exams, some of the things you are supposed to understand is about fertilization, which means fission. And whenever you see a sperm plus an egg joining, that is fertilization. You are supposed to choose fertilization. When you see attachment to the uterine lining, choose implantation. Then we go to question number 29. Implantation occurs when the developing embryo attaches to the lining of the, we have A, stomach, B, uterus, and C, kidney, and then D, lung. That is very, very easy. The correct option is B, the uterus, because implantation is the attachment of the baby developing embryo, specifically the it is called the blastocyst at this stage. So it moves to the uterus. Now it moves to the lining of the uterus, and this allows further development to continue in the uterus. The stomach is part of digestion, the kidney is part of the urinary system, and the lungs are involved in gas exchange. They have nothing to do with reproduction. Now let us move on to question number 30. Question 30. Which one of the following may be a warning sign of a sexually transmitted infection and should be checked by a health professional? A. Persistent unusual genital discharge. B. Feeling hungry before lunch. C. Sweating after exercise. D. Feeling sleepy at night. That is a very easy question. The correct option is A. Persistent unusual genital discharge, because such a symptom can be associated with STI, and it should be assessed by a qualified healthcare professional. Other possible warning signs that you can encounter in your exam include, for example, sores, that is common, and then unusual pain or pain during urination. Some of the infections that can occur without obvious symptoms, so that is also a possibility in case it is tested. And you should always know that people are not supposed to diagnose themselves. They are supposed to seek medical advice. They cannot use a single symptom to diagnose themselves, because again, symptoms can be associated. Pain during urination is not only caused by UTI or STI, it can also be caused by other things. Now, hunger before lunch, sweating after exercise, and sleepiness at night, those are normal experiences and they are not in any way related to STIs. So for you, you are supposed to recognize possible symptoms and know the importance of preventing and seeking appropriate health care. With that, now we go to question number 31. So question 31. Which choice is the most appropriate way for grade 8 learner to prevent STIs? Sexually transmitted infections is what I'm calling STIs. We have A. Abstaining from sexual activity. B. Sharing needles with friends. C. Ignoring health information. And D. Taking medicine without medical advice. Now that is very easy and something that every grade 8 learner and other students should do. The correct option is A. Abstaining from sexual activity. For a grade 8 learner, abstinence or abstaining from sexual activity prevents the sexual transmission of infections, and it also avoids other risks that are associated with early sexual activities. Other things like sharing needles, this is dangerous because bloodborne infections can be transmitted that way. Ignoring healthcare information is going to increase risk, so the other options are not correct. Then now with that, we are done with reproduction in human beings. When a question is asked in that topic, even if it is twisted in another way, you should be prepared to handle it. Then now we go to the next heading, transformation of energy. We are done with reproduction. Now we are moving on to energy, transformation of energy, and we are covering question 32 to 36 in that area. So we start with question 32. Question number 32. Which one of the following is a renewable source of energy? We have A. Coal, B. Solar energy, C. Diesel, D. Natural gas. So for question number 32, that is not hard. The correct option there is B. Solar energy. Because solar energy is a renewable energy, because sunlight is naturally replenished and it can be used repeatedly on a human time scale. Coal, diesel, and natural gas are non-renewable because they come from finite fossil fuel resources that take extremely long period to form. Other renewable sources of energy that you may encounter, they include wind, moving water, and geothermal energy. Those are renewable. And renewable energy does not mean that a source has no environmental effects. It means that the source is naturally replaced fast enough to be used again. Now, for you, you are supposed to understand things like classification of energy resources, and you are supposed to understand why the society uses different sources. For your exams, you are supposed to ask yourself whether the source can be naturally replenished in a relatively short time, like sun, wind, water, and geothermal energy, which are renewable. But fossil fuels, those are non-renewable, and they take so long for them to replenish. Then we go to question number 33. In a dry cell, energy is mainly transformed from, we have A, chemical energy to electrical energy, B, sound energy to heat energy, C, light energy to chemical energy, D, electrical energy to nuclear energy. Now, the correct option there is A, chemical energy to electrical energy, because a dry cell stores energy in form of chemicals. Then when connected in a circuit, the chemical reactions in the cell make electrical energy available to the circuit. The other options do not describe the main transformation in a dry cell. And an example, let me give you other examples. A solar panel changes light energy to electrical energy, while a generator changes mechanical energy to electrical energy, while electrical heater changes electricity energy to heat. So for your exams, when you get this kind of questions, what you are changing to what, you are supposed to identify what form of energy enters a device and what useful energy comes out of it. For example, for batteries and cells, think of chemicals coming in and then electrical energy. For torches, for example, it is chemical energy that is transformed to electrical energy, and then that electrical energy transformed to light. For radios, it is chemical energy. For radios that is using battery, it is chemical energy transformed to electrical energy, and then that electrical energy transformed to sound. It is very, very important for you to understand those transmissions. Then now we go to question number 34. An electric ion mainly changes electrical energy into, we have A, heat energy, B, chemical energy, C, nuclear energy, and D, gravitational energy. Now, after addressing question 33, I know that this one you know. The correct option is A, heat energy, because an electric ion uses electrical energy from the power supply and it converts much of it into heat in its heating element. Now, the heat is then transferred to the clothes. The ion does not mainly produce chemical, nuclear, or gravitational energy, so the other options are wrong. Many everyday appliances can be understood through energy transformation. An electric bulb, for example, changes electrical energy mainly into light and heat, and then a motor changes electrical energy into mechanical motion. Then a speaker changes electrical energy into sound. And then what about a kettle? A kettle changes electrical energy into heat. When you come across such kind of questions, remember that for appliances questions, you are supposed to focus on the main useful output. What do you get out of it? If it is a kettle, you need heat. If it is iron, you need heat. So it is electrical energy to heat. Then we go to question number 35. A stone falls from a height. Its gravitational potential energy is mainly changed into. So as a stone falls from a height, its gravitational potential energy is mainly changed into A, kinetic energy, B, chemical energy, C, nuclear energy, and D, magnetic energy. The correct answer there is A, kinetic energy, because a stone held above the ground has gravitational potential energy because of its position. It is high up, so it has gravitational energy, and then as it falls, its height decreases and its speed increases. So gravitational potential energy is transformed mainly into kinetic energy and the energy of motion. When the stone hits the ground, some of that kinetic energy can change into sound, heat, and deformation. The other options there, they are not correct because they are not the main transformations that occurs during the fall. For your exams, when you meet such kind of questions, remember that the potential energy is associated with position or stored energy, while kinetic energy is associated with motion. When an object falls when an object is falling and speeding up, think of potential to kinetic. Then question number 36. Which safety measure helps to protect a person from harm caused by very loud sound? We have A, increasing the volume, B, staying close to loudspeakers for a long time, C, reducing exposure and using hearing protection where necessary, and D, blocking ventilation in the room. So for this question, the correct option is C. You are supposed to reduce exposure and using hearing protection where necessary, because very loud sounds can damage the structures involved in hearing, especially when the exposure is intense or prolonged. Increasing the volume or standing close to loudspeakers for a long time is actually going to increase the risk and not reduce it. Yes, with that, we are done with question number 36. And now we are ready to go to question number 37. So we are done with the transformation of energy. Now we are learning about pressure. In this last part, question 37 to 40, 40 is our last question. We are learning about pressure. And we are going to begin with 37. For the same force, pressure on a solid surface becomes greater when the area of contact A, increases, B, decreases, C, remains the same, and D, becomes wet. So for this question, the correct option is B, when the area of contact decreases, because pressure on a solid depends on how force is spread over an area. If the same force acts over a smaller area, the pressure becomes greater. And if the area increases while the force stays the same, the pressure becomes smaller. This explains why narrow objects can press more strongly into surface rather than broad ones. The word same force is important in the question because it allows us to compare the effect of the area alone. When you get such kind of questions to the exam, the tip is to remember this, that for the same force, remember the inverse relationship. Smaller area gives greater pressure. Larger area gives lower pressure. Read carefully so you do not reverse the relationship. Then let us go to question number 38. A sharp knife cuts more easily than a blunt knife, mainly because its edge A, has a smaller area and produces greater pressure, B, has a larger area and produces less pressure, C, has no mass, D, removes all friction. So for question 38, the correct option is A. A sharp knife has a smaller contact area and therefore produces greater pressure for the same applied force. This is because the force is concentrated on a thin edge. The material is therefore easier to cut. A blunt knife spreads the same force over a wider edge, producing less pressure. And this principle also explains why needles and nails have pointed ends and why high-knitted shoes exert more pressure on the ground than the broad ones. You see, flat shoes carrying the same weight will have lower pressure. Now, the knife does not have mass and cutting is not explained by removing all friction. An exam tip here is to remember that when an object is designed to pierce or cut, look for a small contact area. And when an object is designed not to sink into a soft surface, look for a larger contact area. Then question number 39. How does pressure in liquid change as depth below the surface increases? A, it increases, B, it decreases to 0, C, it remains exactly the same, D, it changes into heat. The correct option here is A, that liquid pressure increases with depth. The deeper the point is below the surface of a liquid, the greater the weight of the liquid above it. So the pressure is greater. This can be demonstrated using a container with holes at different height. Water from the lower holes tend to travel further because the pressure is greater lower down. Liquid pressure does not become 0 with depth and it does not change into heat, you see. Now this concept helps to explain the design of dams and other structures that hold large amounts of water. An exam tip for you is to remember that in a liquid at rest, deeper means greater pressure. If a diagram maybe shows several holes at different depths, this is a question I have noticed they like to test. They give you a diagram showing several holes at different depths. You are supposed to expect or to explain that the lowest hole will show the strongest outward effect, or the water will go further because the pressure is higher at that level. Then now we go to the last question, question 40. Which device is an application of pressure in liquids? A. Hydraulic car brakes. B. A dry wooden ruler. C. A candle flame. And D. A bar magnet. So for question 40, the correct option is A. A hydraulic car brake, because car braking systems use a liquid to transmit pressure from the driver's input to braking components at the wheels. And this makes the pressure in liquid useful in practical devices. Other examples from this topic include syringes and some pumping system. A wooden ruler, candle flame, and bar magnets, you see, they do not demonstrate an application of pressure in liquids. Those other options are not correct. The broader lesson for you to remember is that pressure occurs in solids and liquids, and it can be useful when it is controlled properly. So in solids, the area of contact is especially important in liquids because pressure acts through the liquid and it increases with depth. For your exams, when you encounter such a question, remember that if you are asked for an appliance of liquid pressure, look for surface containing liquid that transmits force or pressure, such as hydraulic brake. And with that, we are done with this paper of integrated science. That is the last question. And that brings us to the end. I hope that you did get to learn so much. I hope that you learned. I hope that also you tried to answer the questions before you got the answer. Thank you so much for watching. Check out our channel because we have more videos. Bye bye and see you in the next video.